Hello scientists, it's PS Science here, and today we're going to be discussing the anatomy of the human eye and how the anatomy of our eyes, along with light and our powerful brains, allow us to see. Are you ready to take a closer look? This is a model of an eye. If you think about the size of our eye, what do you think? Seems a little bit larger than our own eyes. Human eyes are about the size of a golf ball, and the part that we can see is actually the smallest part of our eye. Our eyes are set back in our skull in something called an eye socket. So I want you to take your two index fingers, and I want you to do this gently, but find your brow bone above your eyes with your fingers. You can feel the bone right underneath your eyebrows, and then tap around with your fingers. Follow the bone, go out on the side of your eyes, and then go down along your cheekbones, and then go back up. If you look to the side, if you look at anybody else or you look at yourself in the mirror, you can see that our eyes are set back into our skull. They are set back into the eye socket, and that's to give our eye protection because our eyes are actually soft. Now the inside is a liquid called the vitreous humor. I don't know if you think that's funny, ha ha ha. But the outside, the white part, is called the sclera. That kind of gives our eye shape, makes it solid on the outside. So this bony protection of our eye socket helps to protect the softer parts of our eye from being damaged. I'm going to take apart the eye model, and we're going to take a closer look. As I said, the outside of the eye, the white part, is called the sclera. And if we could take our eye out of our socket, you would see that actually there are bands of muscle all around the sclera and attached to the sclera. Think about that. Take a look left. Take a look right. Look all around. Your eyes move all the time and you don't even have to think about it. Powerful muscles are attached to our eyes. Now, if we could take this down in layers, you can see on the edge here a clear part that bulges out. That's actually the part of the eye called the cornea. Now, the cornea is clear, and the main purpose of the cornea is to focus light that enters the eye through the pupil. If you look straight on, there's a black dot in the center. That's the pupil of our eye. And the pupil is what allows the light to enter our eye into the inner chamber. Now, our pupils can contract or expand depending on the light conditions. Think about when you go out on a sunny day, right? If you go in from a regular room and you go out into the blaring sunshine, what is the first thing that you do, right? You squinch up your eyes, you want to squint, you want to cover your eyes. That's because there's too much light energy, and it takes a second for your pupils to shrink down so that they're letting in less light. So, do you want to take a look inside? I'm going to take this apart, just set it down for a second, and as I open up the eye, you can see that there are several parts. Great. Several parts that are now broken on the floor. As I take it apart, you can see that there are a whole bunch of blood vessels and nerves that run along the sides of your eyes. This is another layer deep. And you might notice the little blood vessels in your own eye, especially if you've been on the computer a lot. Sometimes you can see little tiny red blood vessels. There are nerves and blood vessels in this layer of the eye. And underneath the cornea, there is something called, that's the pupil. And the pupil allows the light to enter that inner chamber of the eye. Let me take this out. And let's go another layer deep. Take this apart. Oh. Now what do you think, scientists? Look at this part that bulges out right here. Have any idea what that is? That is the lens. Just like a camera, you have a lens in your eye. So you've got the cornea on the outside, right? And then you've got the lens, and both help to focus the light energy that's entering the chamber of the eye. So as the light goes through the cornea, enters the eye, through the pupil, passes through the lens, it's focusing the light onto the back of the eye. And the part of the eye that receives the light signals is called the retina. It never hurts to go over it more than one time. So let's think about the light that's entering the eye. There's the cornea on the outside, which focuses a lot of the light that enters through the pupil. And then underneath the pupil, there is something called a lens, very much like a camera lens, which further focuses the light onto the back of the eye, which is called the retina. The back of the eye, the retina, is almost like a movie screen. And the retina absorbs the information from the light images. Now, that information gets sent along a very thick nerve at the back of the eye, which sends that light information to your brain. And it's only when it gets to your brain that you're actually seeing the images that have entered your eye. Now, what's really cool about eyes and light and images is that light travels in a straight line. And because light travels in a straight line, the images that enter your eye are actually upside down on your retina. And only when they get to the brain via the optic nerve does your brain interpret the information and flip the image so that what you see is right side up. Interesting, right? Let's look at a diagram so we can figure that out a little bit better. Here's a great diagram, and go ahead and pause the video if you want to take a closer look. Because of the way light waves travel in a straight line, that image on the back of the retina is upside down. You can trace the light wave with your finger from the top of the tree to the back of the eye, from the bottom of the tree to the back of the eye, and understand how the image gets flipped. That colored circle is called the iris, and the iris is very muscular. It also helps to focus the light, and it gives you the character of the color of your eyes. Let's take a look. Think about your eyes, think about the anatomy of your eye, and then think about light and eyes and the anatomy of your eyes, and then think about your brain and light and the anatomy of your eyes. Eyes are really amazing, and as small as they are, think about what they do for us. Think about your sense of sight, and think about light. Think about light and your eyes, and think about light, your eyes, and your brain. What would you say, scientists? Couldn't you see without light? Can you see without eyes? Can you see without your brain? Why don't you go ahead and pause the video and jot down your ideas. I'd like you to explain how light and eyes and your brain all work together to give us our sense of sight. Thanks for joining, scientists. We'll see you again the next time. See you again the next time. Okay, scientists, thanks for watching. Did you enjoy that lesson? Subscribe below to see more fun science videos. You can also become a member of PS Science on Patreon to support what we're doing. See you next time.